So let's look at the definite integral from x equals 3 to 9 of x plus 4 quantity squared dx. Our first step that we want to do is find the antiderivative. It might be possible to do that directly, but instead what I'm going to recommend is that we expand this algebraically. The reason I'm going to recommend that is we probably know at least one antiderivative rule by heart, or we convince ourselves that this one antiderivative rule is true. It's not too hard to see that the antiderivative of x to the n is 1 over n plus 1 x to the n plus 1. We could have an arbitrary constant added on. But to use this rule, we have to make it so that we're dealing with power functions. I want to expand x plus 4 times x plus 4, and when I do that, I'll get that this expression is equivalent to the definite integral from 3 to 9 of x squared plus 8x plus 16 dx. You can find the antiderivative of x squared plus 8x plus 16 dx, and I'm going to use this trick about the antiderivative of x to the n is 1 over n plus 1 times x to the n plus 1. Instead, it helps me if I rewrite this as 8x to the 1 and 16 times x to the 0, since x to the 0 is 1. So the antiderivative of x squared is 1/3 x cubed plus 8. You can just keep the numbers in front, just like when you're taking derivative. Then this becomes 1/2 x squared plus 16, 1 over 1, x to the 1. And if I clean this up a bit, this becomes 1/3 x cubed plus 4 x squared plus 16x. So now I have found the antiderivative, and I'm ready to move on to the next step. Remember, it's commonplace to call this big F of x. And as I've mentioned before, I'm really hoping that someday there will be a Houston rapper called Big F, because then the mean potential will be unlimited. So we're trying to do this definite integral. We did step 1. We found the antiderivative, big F of x. And now it's time to evaluate that antiderivative at the bounds, which means in this case, we're doing big F of 9 minus big F. So all we have to do is plug in. We have 1/3 times 9 cubed plus 4 times 9 squared plus 16 times 9 minus 1/3 times 3 cubed plus 4 times 3 squared plus 16 times 3. So the purpose of this question is to illustrate that many times it's easier to do these problems if you try to expand algebraically. Now the truth is, we live in a world where you can just type this into a computer and don't have to worry about expanding, which kind of makes this a philosophical discussion at this point. I guess the thing I want you to get out of it is sometimes there are different ways to solve problems if you just take one extra step to change the way that the problem looks.